right, so let's talk about some different algebraic forms in action. Woo. So, number one, what is this type of algebraic production form called that I am writing on the screen? Linear, very good. And so we're asked, what's Q when there's 3 units of capital and 7 units of labor? So how do we evaluate this? Well, we literally just put the 3, right, the K into the K, so put the 3 there, and then we put the L, we just plug and chug. Well, I shouldn't say just plug and chug. We plug and chug. Does everybody understand how I got to this point? Just replacing the K and replacing the L. Excellent. So we end up with 9. 6 times 7 is 42. 42 plus 9. We end up with a quantity of 51. So when we're talking about that marginal product, right? So we define the marginal product extensively. But what about algebraically? So the marginal products in a linear form are going to be whatever the coefficients are for that particular capital, okay? So if we have, so let's just do a generic example here. Q is equal to A times K plus B times L. In this particular example, we'd have a marginal product of capital of A and a marginal product of labor of B. Now, on your own, I want you guys to give your best shots at the average products. So what's the average product of capital and what's the average product of labor? Just the generic form. All right, so anytime we take the average of something, what does that mean? That means that the next thing that we have, we're going to divide it by something, right? So this time it's going to be divided by the capital. So it's the total product divided by the capital. Well, what's the total product? Well, we know the total product is equal to Q. So what's Q? Well, we know that Q is equal to AK plus BL. So that's our average product of capital. That's our average product of labor. So things get a little bit more hairy when we start to talk about the other production functions. Doesn't actually make sense to really talk about the marginal product in the Leontief production function, right? Because in that example we had in the Kahoot quiz, right? You know, what's the marginal product of the 10th unit of capital? 0, right? Because it was a minimum of the capital and the labor. There was 9 units of labor, 10 units of capital used. There was only 9 units produced. So that 10th unit of capital had no marginal productivity. So these notions of marginal and average productivity kind of break down when we're talking about Leontief. So we don't even really discuss them or define them. But when we are talking about cobb-douglas production functions, right, which, like I told you guys, that's the default, that's the standard in all graduate economics stuff and a lot of the existing literature, right? So when we're using a cobb-douglas production function, and just for our entertainment here, go ahead and just give me your best guess at what a cobb-douglas production function looks like. Just write it down on your own, and then I'll come around. Excellent, excellent. Looks great. Everyone's doing a wonderful job. You're absolutely correct. It is k to the a power times L to the b power. So prepared. And each one of these exponents, right? These exponents we know are less than 1 and greater than 0. And so our marginal products here take a little bit of calculus to really understand, which we're not going to do in this class. So we're just going to memorize that our marginal products when we have a cobb-douglas production function, the first one's going to be equal to A times K to the A minus 1 times L to the B. So for any of you that care, this is the partial differential of that function with respect to K. And for the marginal product of labor, it's going to be B times K to the A times L to the B minus 1. And if you understood the first thing, you'll probably have guessed that this is no more than the partial derivative with respect to labor. Our average products are constructed in the same way that we constructed the average products of the linear function. So the average product of labor is going to be equal to the total product over L, which is equal to Q over L, which is equal to K to the A, L to the B over L. And then the book doesn't take it any further than this, but this is actually not the complete solution. So anybody that knows math will probably be aggravated if I don't solve this, because this is L to the 1. When we bring that to the numerator, we end up with K to the A, L to the B, L to the negative 1. What can we do when we have two terms that have the same base, right? When we have x squared and x to the third, that ends up equaling x to the 2 times 3, right? X to the 5th. Just one of our properties of exponential math. And so this same thing happens here. So it ends up being K to the A, L to the B minus 1. But again, this part the book doesn't tell you, doesn't require you to know, so you probably don't care. So how much would the firm produce according to this very common production function? Suppose that we have a production function and we are going to hold the amount of capital equal to 1 for simplicity, and we're told that A is going to be equal to 1/4 and that B is going to be equal to 3/4. Right, so we fixed capital, and at this point now we can go ahead and calculate what our marginal product of labor is at some certain 16. So at 16, when K is fixed to equal 1. So in order to calculate this, right, we would use our marginal product of labor formula. And so we would take that B, right? We would have that B be in the, let's probably do it down here actually. So we'd have the B be the first thing, right? And so the B is the 3/4. 3/4 times 1 to the 1/4 power times, and then this is going to be L to the what? To the B minus 1. So 3/4. What's 3/4 minus 1? Negative. So the way to do this easily is you do 3/4 minus, and then you just convert that 1 into a fraction. So that way it's very easy for you to see 3 minus 4 gives us negative 1/4 on the numerator. What's 1 to the 1/4 power? What's the quadratic root of 1? What times 1 times 1 times 1 equals 1? 1. 1 to the any power is 1. So 1 to the any power is 1. So this is 1 times 3/4 times, and then we're told L is equal to 16. So now we're going to go ahead and plug that in there. 16 to the negative 1/4. Now 16 to the negative 1/4, anytime we have something to the negative power, the easiest thing to do, and 3/4 times 1 is just 3/4, right? So this ends up being 3/4, and then times this 16 to the negative 1/4, I'm going to take it to the denominator so that the negative goes away. And then what times what times what times what gives us 16? What's the quad root of 16? 2. Very good. So this ends up being 3/4 times 1/2. So we end up with 3/8 as our marginal product of labor. Questions on that? All right, and we've got it recorded, so that's good. I should start chopping these up more, so I'm going to stop it right now.